Hypothesis 1 was something about if I add if 3 times more nitrogen fertilizer is added, then the beans will produce 3 times more in mass because nitrogen is necessary for bean metabolism. Is this accurate?
That was number 2.
That was then hypothesis 1 was something like, if you give beans fertilizer, then they will grow because they need food. Okay. Which was the good one?
2.
Why?
Specific.
We use science words.
It didn't just say like, it was more specific on the fertilizer stuff.
You did research before writing your hypothesis?
Yeah, science words means we did some research, right? Hey, I'm left-handed too. My mom always said we're special. Look at us. Anybody else? Southpaws? Are you just holding it with that pen or that hand? Gee, I wonder how I guessed that. So it was specific, and 3 times and 3 times implied I could make a measurement, right? I can measure how much fertilizer I added, and I can measure mass. So it also leads us to measurements. A well-crafted hypothesis is ridiculously important in making a good experimental design. So in creating a good procedure, it is important because it's going to influence how we write our procedure. If I write if, then, because, what I fill in at the if is the independent variable. And what I fill in at the n, or the then, is the dependent variable. Now, grading your read and take notes quizzes yesterday, I did notice there were a fair number of you who confused the independent and dependent variable. The independent variable is the one the researcher changes deliberately. So in the instance of my fake hypothesis, that's how much fertilizer I've added. So that's the one the experimenter deliberately changes. The dependent variable is the one that changes in response to whatever the experimenter did. So that's how we can tell the difference. So let's see. We made an observation. We asked a question. We did some research. We asked a better question. We wrote a hypothesis. And then what do we do?
Experiment?
We're going to design our experiment. And when we design an experiment, our good experiments are always going to have an independent and dependent variable. They're going to have constants and they're going to have control groups. Now, I'm not going to cover what those other 2 things are because based on your do-nows from last week, you're like, please, I totally know all this already. Is this accurate?
No.
I had some yeses and some nos.
I said yeah.
Oh, yep. You're like Daryl from Storage Wars.
I hate him so much.
He's not particularly likable. Cam's likable. I like Cam. He walked around the room and signed do-nows today for me, so I didn't have to.
I asked everybody how they did. Most people said good.
Well,
Some
that's...
people didn't answer.
Well, it was thoughtful of you to ask. Just don't tip over for me, because I'm getting a little nervous.
Hold on.
Okay, good. She really doesn't want to be taken out by you going backwards. So, for those of you who are like, constants and controls, still not really comfortable with them, we'll talk about them when we review your own experimental designs, for those of you who need it. Good experiments should also collect data. Experiment should collect data. There are two kinds of data. One of them is preferred by scientists everywhere to the other. I'm going to give you guys until the clock says 2:01 to define these two words and determine which one scientists prefer. What is quantitative data?
Data that has numbers.
And qualitative data? Quantitative data typically involves measurements. And qualitative data uses words to describe qualities of things. Qualities of things like color, fuzzy, slimy, you know, qualities, characteristics. Slimy is gross. Now, the follow-up question was, which do scientists prefer? JD?
Do they like them both?
I prefer one over the other.
Oh, okay.
Let's see. Why? Definite answers? So if I were to take out a digital scale to determine the mass of something, is there any way that we could arrive at different masses?
Nope.
It's a digital scale. I'm just going to read it, right? It's going to say 1.345 grams. And you're going to read it, and it's going to say 1.354 grams. But, oh, this doesn't, well, yeah, it works. Rachel?
Yeah.
Do you mind if I use you as an example?
Sure, I guess.
Your polo, I would describe it as blue-red. It is red, but it is blue. I could say blue-red. But the chair you are perched upon, I would describe that as orange-red. Those are descriptors of the colors of those things. How many of you are like, the word red is accurate, but that whole like blue-red, orange-red thing, I've never heard of this nonsense you speak of.
I've heard of blood orange. Blue red.
So
is
take a look
purple.
at these polos. They are red, but they have an undertone of blue to them.
I can see orange red.
And those chairs, their color technically is chili red. That's what the order form said when I ordered them. Chili red, to me, looks like red with an undertone of orange. Now, I love my husband dearly, but if I were to ask him the color of your polo and the color of that chair, he would say red. Red.
Good answer. Half right.
I would disagree. I would be like, no, clearly that is blue red, and that is orange red. And we would bicker back and forth about it, and I would be like, and this is why you have to ask me on Sunday morning when we're getting ready for Mass if you match or not. Because you can't see this. No, he would totally admit that this is absolutely accurate. And he's comfortable with it. That's why I'm the person who chose the paint colors in the house. I'm the person who chose the upholstery colors in the house. I chose all of the draperies. We disagree about something as simple as the color. That fire extinguisher behind Dominic, completely different color. That is red.
Cherry red.
What do you think?
It's cherry red.
Do you see why qualitative things are bad choices?
Yeah.
Yeah.
Because people might not be specific enough when they're recording it the first time, and it makes it difficult for everyone after them. Or people will have different opinions, and then everything.
Just numbers can't be debated, like numbers and numbers.
Unless you do it wrong.
I have to go to the bathroom.
Can I see your planner? And might I borrow an actual utensil of the writing variety? Thanks.
You can have this because I don't know, not mine.
Do your other teachers sign this for you?
So what's my 6th hour?
Sixth
I
hour?
always have just one. Just one.
One what?
I always have only one teacher who actually uses the planner.
You went in 6th hour as well?
Oh yeah.
So quantitative is measurements. Qualitative, they can be biased. They can be opinionated. They involve some value judgment, right? So we prefer, easily, hands down, 110% of the time, we prefer quantitative data. Now I want to warn you about something. Yes? If you what? Well, he's a math teacher. Yeah. I was borrowing one from my English teacher. So, I'm going to warn you. Do not be fooled. Do not be fooled. There is something that looks like quantitative data that is actually qualitative data. I know, it is that the proverbial wolf in sheep's clothing, right?
Sure.
Do not be bamboozled by the Likert scale. Now you're like, I wouldn't be bamboozled by the Likert scale if I knew what it was. So I will provide you with an example of the Likert scale that will immediately assist you in understanding why it is not actually quantitative data, even though it involves numbers. So this whole thing in my abdominal region involves a great deal of pain. The whole process. It's not always the most pleasant. So every time you go to the doctor, they ask you on a scale of 1 to 10 to rate your pain. And I usually look at her like this. 2? And she's like, you seem unsure. And I respond with, I've never experienced pain of 10, I don't think. I don't know how to divide the rest of the scale up, right? And she's like, well, have you ever been in more pain than this? And I laughed, and I was like, I run marathons, of course. Yeah, mile 26, I'd put that at a 5. It's a 5 on the pain scale. And I think this last time I've annoyed her enough by my lack of solid answer that she has now brought me a poster whenever... And 1 has a smiling face, and 10 has a red, angry face, and all of the others are divided up with faces that change accordingly in between, and she asks me which one I feel like. And I'm always like, there's no confused face. 1? And this, to me, is a dreadful system of measurement. A 1 to 10 scale that is completely an opinion. And this is where I'm going to throw dear husband under the bus again. I totally called it. Victory. I mean, are you okay? Okay. This is where I throw dear husband under the bus. If he were to have to answer, he would probably say 8 or 9 every time. No matter what it is, stubs his toe, but it's an 8. I worked out, muscle soreness, but it's an 8. No matter what it is. The Likert scale is always going to be subjective. So even though it's numbers, not quantitative.
So, in a competition, say that they give you, a number out of 10, for different categories and stuff. And the first person, I feel has
A distinct disadvantage.
yeah, because they don't have anything to base it off of.
That was always my problem with any competition that's rated on a scale of 1 to 10. Or any scale, like gymnastics or figure skating or any of those where they rank you, with the judges sit and rank you and hold up signs or whatever. This to me is perplexing because it's so not scientific, right? I don't know how to do that. Even if you put smiley faces and frowny faces and like anger shooting out the ear faces, still means nothing. Like what would, like, how do you choose that? Like, I can't wait until I deliver this child and be like, here's your pain scale. And I'll be like, I don't know, like 7 maybe?
3.
It's like when I got my appendix out at the doctor's office, every day they'd come to me and tell me, rate your pain. I just look at them and they got really annoyed at me.
I think it's a meaningless scale. Some of you, oh look, it's another Likert scale. God bless America. Strongly agree, strongly disagree, undecided,
I do.
not the not applicable, or the unobserved. We all love that scale, right?
Sure. I hate
I will never give you one of those scales, by the way, because you can tell my loathing for them.
Dominic.
Now you fell and you went in the cupboard. I don't know, it's bad.
Who is the third one? You're next.
Yeah, we'll see about that.
Rachel, could you please stay upright?
So I haven't found out yet.
Yes.
I was gonna say you might want to find some wood to knock on, because I would say that and then.
Right there.
3 seconds.
This is not wood.
No, I'm too lazy to actually move, so.
Oh, you're gonna fall then.
So the other reason that we like numerical data, other than, we like things that are repeatable, we like things that we can analyze. There are a couple of kinds of data analysis. One of them is one actually both of them, you can thank Mr. Murphy for.
I had him last year. He's great. He's hilarious.
Very, very basic statistical analyses like mean, median, and mode. It's really hard to determine the mean, median, or mode of red.
He's red.
Yeah, all of a sudden you're like, red divided by 0 does not exist. Right?
Undefined. Undefined.
Have you ever asked? Okay, I shouldn't ask you guys to do this.
All the time.
I can't wait until I ask you out. Please excuse my dear Aunt Sally.
But he does a dance too. So
Yeah, oh yeah, that was the best.
God love him. So, you can't do that with red. It doesn't work, right? Even red divided by 1.
It's red. More red.
Red divided by 1 is red.
Red divided by 2.
So red is the very.
Red divided by 2 is 1/2 red.
So,
Red divided by 1 is still red.
we see how this doesn't work, right? But if I give you a data set, you can easily find mean, median, and mode if it's quantitative.
Yes.
The other thing you can do with it is create a graph. I do want you to be aware that the vast majority of good experimentation, in fact, all of the experimentation I ask you to do in here is going to involve making a graph. And there are 2 kinds of graphs that make me frowny and 2 kinds of graphs that make me smiley. Yeah, on the 1 to 10 scale, there are 2 kinds of graphs that are a 1, and there's 2 kinds of graphs that are a 10, and I don't know that there are any graphs that exist in between. As a scientist, we really are frowny faced at pie charts and bar graphs. And you're like, oh, but I like those. Those are the easy ones. Yeah, that's why we frowny face at them. They are the kinds of graphs that are used for, I don't know, counting the numbers of things like, there are 45 sprinkle donuts and 15 chocolate glaze. Meh. What do I care? I don't like donuts. Sorry. You guys are like, you know when I started going to Donut Sunday after Masses? When they started buying bagels. Two. Frowny, bar, and pie.
I'm good.
Smiley, line, and XY scatter. And this has a lot to do with number 1 again. I cannot determine the slope of a pie chart. I cannot do y equals mx plus b for a bar graph. But if I have a line graph or an XY scatter plot, most of you guys consider them the same thing. We'll go through some nuances later. If I have one of those, I can in fact determine an algebraic equation for my line, right? And in doing so, I can extrapolate, I can put in new data points and make a prediction. Scientists rely on that level of accuracy. We rely on that level of precision. That kind of data analysis is important to us. So now you're thinking about your own experimental designs and you're like, oh shoot, I'm pretty sure I made a bar graph. That's okay. I didn't tell you this in advance. Like I said, there are some people who are distracted by not even their iPads.
I'm moving chair. Hey, when you go to the bathroom, can I borrow your chair?
Captive in this room, and there's nothing I can do about it.
Should have fallen to Molly.
So, last piece of advice for your experimental design as far as graphs go. If you are going to make a graph, you're always going to mix it dry. And what that means is you're going to put the manipulated or independent variable on the x-axis. You will put the manipulated or independent variable on the x-axis and the dependent or responding variable on the y. That means when we graph it and we do that whole y equals mx plus b thing, we are going to determine a relationship that involves rate of change. And it will make sense that way. If you graph it in any other way, it won't make sense. Now, again, gonna skip over some of the finer points of independent, dependent, responding, manipulated, because you told me that you're champions at it already. No?
Ultimate Frisbee too.
Yeah.
Well, that's good. After you have made this graph, you are going to draw a conclusion. So we experiment, we collect data, we draw conclusions. Oh, I should have told you guys also as well. We collect data in the metric system in this room.
Oh, no.
We do not use the US system here.
Yeah, US is stubborn. They change everything.
The US freezes like.
I personally prefer the kind of math where I just have to slide decimal points
Yeah.
rather than like
12 plus 12.
12, 36, 5,000 and something. I don't know. That all seems like town. I didn't memorize those things. Who uses those things? It's ridiculous.
American.
I'm an American and I don't even use those things. Water boils at 212, like I know that.
I didn't.
Freezes at 32. That's really dumb. I like 0 and 100 a lot better. So here we use the metric system. Should have told you that earlier. Conclusions. Your conclusion is simply an interpretation of your graph. It's going to tell you what your graph says, and it's going to tell you whether or not it supports your hypothesis. So it tells you what your graph says and whether or not it supports your hypothesis. You should totally put Yoda back. Here's what you're going to do. You're going to do with this. I had you guys design an experiment for me before I told you the parts of a good experiment. You now have a new way to look at experimentation, where you understand that you're exploring relationships, you understand what it looks like to write a quality hypothesis, and now you have to practice it. But practicing it from scratch is a little difficult, so instead what we're going to do I am going to have you guys share your experiment with another team. So I'll break you guys up. You'll swap teams or swap experiments. And you're going to download the rubric from Schoology into Notability. You're going to mark up the rubric for the other people and tell them how they did. Did they use the bar graph? Was their data qualitative? Was it quantitative? Was there enough of it? Was it in the metric system? You're going to look at it like a scientist. It's the peer review process. It's looking at it and saying, yes, this was good, and no, it was not. Now, we did our best to make this a little bit more objective rather than subjective because we put it on a rubric. That's really just a glorified Likert scale, but it's the best we can do because you guys would just give A's if that's all you had to do. But as I ask you to do this, I want you to look at it from the perspective of a scientist rather than the perspective of a student. Appreciate that some of you are like, but writing it was confusing. I was confused. I know, and that's okay. You're going to get better at it. That's the point. We design our first one, and we're proud of our first one when we get done revising it. And then after our 5th experimental design, we're like, wow, that first one was pretty miserable. Like, I did a bad job. And that's cool. It's growth. I'm fine with that. Personally, how I probably would have done it, if it were me, I would have looked at my 6 characteristics of life from the textbook, and I probably would have chosen respiration. And I would have chosen respiration because I can think of an easy way to measure it. I can measure the output of carbon dioxide. I have a little tool, measures it, it's really easy. And I would have given the different samples different amounts of food, mostly probably sugar water, because that seems like food for most any small organism, and if those things were alive, I'd assume they were small. And then I would have seen if they respired at all. I would have measured their carbon dioxide output. That also would have given me a line graph, because I would have had different amounts of food and different amounts of respiration. If it respired, it's alive, and if it didn't, it's dead. Or not alive. That's what I would have done. But hey, it's just me. What do I have more of than you probably have?
Brains.
No, I'm fairly confident, actually, while yours are still developing and will until about the age of 25, that's really just neural connections. It's not capacity.
Money.
Truthfully, I don't have all that much. I'd share it with you.
You have a card.
Ah, knowledge, right? Experience, background knowledge. For me, that's helpful. I get it, you guys didn't have that. Not expecting brilliance, not expecting Nobel Prize winning science. I'm thinking. I was having a thumper moment. A thumper moment? A thumper moment is